It's a pleasure to see you all here virtually at the World AI Conference. Uh, in the gathering, really, of a group of top global CEOs to talk about the implications of AI, how it's affecting their business, and generally the trends of technology in the world more broadly. We've got together today an extraordinary group of CEOs representing different sectors of the economy, all of whom have extensive experience thinking about not only technology, but thinking about China. And it's a pleasure to welcome them all here today. So thank you all for your time. Reid Hoffman, let me start with you. It's been a year since the last World AIC conference. I think it's the second time you've attended one of these virtually. In that year, you've very much been on the front lines of all kinds of developments in AI. You've sold a large language model company. You sit on the Microsoft board. I'm wondering from your perspective, if you can summarize some of the most important changes you've seen over the last 12 months and what do you see coming next? What's coming around the corner?
Well, generally speaking, if you look at the frontier models, they make massive jumps about every 2 years, and so we're actually still within a few months of that likely happening. A way of framing that would be GPT-5. So a lot of the things in the last year have been multimodal with Sora, have been kind of much more kind of interaction through audio. There's always, like call it every couple of months tuning as well. So like it's like GPT-4 to GPT-4o as an angle on this, and the continued integration in the use cases. But it's a little bit funny to be talking right now about the big jumps because the big jumps are actually probably more later this year than now. So and what people are working on is like reasoning, planning, integration with the internet, memory. That's kind of the pattern at which kind of like all of the top labs are working on. Now, of course, that summary is a massive underdescription of what's going on because there's obviously a ton of stuff going on with getting smaller models to work highly effectively. Anthropic just released a version of Claude that has an embedded feature that's actually, in fact, really good and creates the loop of how humans can work with this in a much more effective way. And so, I could take the entire hour just going through all of the different kind of improvements because it's, still at a speed. But the big jump, I think, is still, later this year.
If you had to characterize those 2 year kind of leaps, are they in speed? Are they in the expansion of the diversity of tasks that can be undertaken? How best to think about those?
Um, Speed is kind of more probably regularly, like every, X months, which X is generally small, like, 2 months, 3 months, 4 months. It's capabilities. It's like thinking about like, okay, we've got um, um, Sora, or we're thinking about with multimodal, or we're thinking about now it can do multi-step planning in a way that executes a kind of a more structured task, or it can be more personalized to kind of individuals in various ways. And so, those kinds of things are the big things, and so they're capabilities in the frame that you've just sketched.
And is your sense that, I mean, one of the big debates, this question of this is it a kind of big gets bigger that the big companies have been able to dominate this space, or as the kind of topology of these models expand, does that create more opportunity for disruption?
I think the usual answer in these things is both. So big companies are continuing to, do the frontier models, do large jumps that essentially the smaller companies can't do. But on the other hand, the fact that you can tune small models to do things that are capable and interesting, whether it's because it's operating on a phone or because it's, doing a specific kind of task or, other kinds of things, this kind of new agentic universe that we see coming is going to actually be a combination of multiple models, in terms of how it operates. And so the fact that there's kind of multiple models, like one of the things I think just came out, kind of in the last week or so in terms of news is OpenAI has, trained a model that helps its training relative to human feedback and other kinds of things. It's helping that loop. So there's not just a whole stack of how these models play in different places. And so the progress is across the board. And so it's not, it shouldn't just be thought that the small models are just a function of speed or of compute envelope. They're also working on what their capability set is too. Now, most of the oh my gosh, I've never seen anything like this kind of capability set tends to come out of the frontier work.
Okay, that's very helpful. Steve, you said something a year ago about AI that I think I've had probably a dozen people quote to me since then, which is you said not only was AI changing the way that you run Blackstone, but it was changing the way you thought about value in companies. That there were a lot of companies that were multi-billion-dollar companies that were going to be $0 billion companies, and things people thought were $0 billion companies that might be multi-billion-dollar companies. I'm wondering, as you've kind of advanced in your commercial thinking about the intersection of what you do at your business with AI, what are you seeing in that regard? How is it changing, both, I guess, to some degree, the inside of how you're running Blackstone, but I think I'm more interested in the question of how does it affect the nature of the value of the businesses that are out there already?
I think, as I said last year, Josh, some businesses really adapt extremely well to aspects of AI, and other ones not as much. And so, we always take this into account now, when we're looking at any potential investment. And just to give you an example, we have one of our portfolio companies in the contract automation business, and they've taken the installation of one of these uh, pieces of software from 7 minutes to 30 seconds. And it would take a long time to spread that 7 minutes. And now it just happens almost instantaneously. It saves a customer a few $100,000. And, we can just not charge them anything for that. And now our business is really growing much, much faster because it's cheaper for this particular type of product for the customer. And so we see these types of things. We're getting efficiencies in places we wouldn't have seen. We own a company called Signature, which is the FBO company for private planes, and we can better predict, when a plane's actually going to be there. So you use your equipment on the ground with, sort of much more efficiency. We're using this at the firm. It was good to be a young person now because you can have AI help doing your models. I struggled with that when I started. I wasn't much of a numbers guy, so we see things of that types. They can even do a bunches of first drafts of investment committee memos, which that surprised me as well. And as everybody on the panel knows, these are early days, for AI. And I sort of look at the whole thing. I'm reading a book now on the invention of the modern electricity with Thomas Edison against George Westinghouse. And I'm looking at this and I'm saying, my God, this seems like the same thing. Who's going to build the grid? What are you going to put on that grid? Nobody knew back then. They didn't know about radios and televisions and all kinds of other things that ended up developing. So, we see this moving along quite well for us. But it's, I've kept people's expectations low, but their fear high. I want them to be scared that if we don't be a very rapid adopter and our competition does, then we are the people at risk. And we can't be ostriches, sort of with our heads in the sand, not understanding the profound nature as this technology really starts rapidly developing.
One of the things on that point, I mean, just on risk, one of the things you've certainly pounded into my head over the years is just the way you think about risk. I mean, I've rarely encountered anybody who is as kind of both philosophical and tactical in thinking about risk. Has AI changed the way you run your risk meetings, the way you price risk into investments?
Well, I have a saying: there are no brave old people in the investment business, it's always good to be concerned about what can go wrong, and this gives us a dual look. It shows us, what can go right and really make something work, and it also shows us that there are just certain business areas you don't want to touch because AI can just rip your heart out once it gets developed. It doesn't have to be, we make investments. We're not like stock investors who can trade out of something if they don't like it. We own hard assets. And so we have to look at something over a 5 and 10 year period and sort of assess. I was going to use the word guess, but I like assess better. What's going to happen to that kind of business if AI develops in a certain way? There'll be big winners, and there'll also be losers. We just don't want them to be, sort of unexpected losers. So that's how we look at it. It's totally part of the way we look at things now.
Jenny, moving from kind of the private market space to the public market space, obviously a big story, if not the big story in public markets this year has been AI and the way that has kind of changed the energy of the markets themselves. You're obviously in that space at huge scale every day. What's your sense of this? How does this AI, I mean, is it an AI bubble? How does it look like in terms of the way investors are thinking about the market?
Yeah, I mean, so what you've first seen as far as the successful companies, I call it the picks and shovels, the folks selling picks and shovels to support AI, right? It's the cloud services, it's the NVIDIA chips. That's always kind of the first phase. The second phase, which is what we're going into, and Steve talked about it, is we'll call it the application phase, right? So it's those who are figuring out what to do. And honestly, the first part of that is really the LLM models, the Microsoft Copilot. When Apple comes out with their next version of AI in China, it's Tencent, Baidu, and Alibaba who have the LLM models in Chinese. That's going to train a world of business people on starting to understand how to use it. If you look at history of technology when it's kind of first adopted, right? The first thing people do is they optimize what they do today. They don't really think through the breakthrough of what you can do. But in order to get the breakthrough, right, you have to actually understand how to use it. And so this phase of people starting to get more comfortable with, say, a Microsoft Copilot in your day-to-day applications is going to start to get people more comfortable with thinking about AI. And that's where that next phase is going to be. And I think firms, one, who have kind of a culture of what, Steve says, which is a willingness to take risk, appropriate risk around recognizing you're not always going to get it right with AI. So some of the things that you're going to do are dead ends, but you got to spend the money trying to invest and learn from them. And then figuring out where they can actually add real value to your business. And then no question, it's optimizing the back office. So, we rolled out these were just simple pilots, right? Where like one of them is a bot that's answering help desk questions of our 10,000 employees, right? You know what? It's retiring 60% of them on the first shot. That's an efficiency. Is it going to change our financial numbers? No, not significantly yet. But as we get better at it, we have another one that's doing FX, reconciliation. It went from 80% to 97% or something, right? Those are efficiencies that we get to reinvest. And then as we're learning from it, we can leverage it in areas where it really makes that competitive advantage in the investment side, in our client service and distribution side. And so I think that's kind of the phase two that we're just getting in and figuring out which companies are going to be good at that, are going to be the ones that succeed in their sector.
Franklin Temple's very well known for being I don't know the right way to describe it, but a risk-taking organization. You're willing to go into frontier markets, willing to go into China, willing to go into technology spaces very early. Are you seeing that it's harder or easier to kind of keep that risk-taking perspective among your team when they're faced with this technology that, like you say, is transformative in terms of what their jobs will be?
Now you're scaring me because Steve just said, the brave, there's no long-term brave investors. No, look, we're third generation, even though we're a public company, third generation. We've always had the perspective of how do you think about the business long term. So if you think about the fact that we were early into markets locally, right? It was actually a very obvious trend. 80% of flows in any market goes to domestic products. So we would set up local asset management, and that differentiated us from many of our competitors. I spend 30% of my time, I try to really focus on saying I should spend 30% of my time on disruption, making sure I'm understanding AI, making sure I'm understanding blockchain, because as we think about how the business is going to change, you have to have that top down to ensure that people recognize it's important for everybody to be thinking about it. And I think it's that kind of family, multi-generational approach and thinking that unfortunately, so many public companies don't have the luxury. Blackstone does because of the way that Steve has structured the governance around that. We do because the original founders still own a significant share of the stock. So we'll, make investments today, honestly, that we know may not pay off material for 5-7 years, but we have to make them today. Whereas a lot of public company CEOs are, end up being so focused on quarterly earnings, and the payoff isn't going to be in their tenure as a CEO. And so they don't necessarily invest it. And those are the ones who aren't going to succeed in this time of great, change.
That's very interesting. Ola, maybe I turn to you on that. I mean, Mercedes obviously is a, run like a multi-generational company in terms of the values, the way that you operate. And you're an industry that's being kind of simultaneously, as I see, kind of revolutionized from many different directions, from the nature of, whether it's, moving away from internal combustion engines to autonomous driving to people's habits and shifting patterns of urbanization. I'm wondering, where does AI fit into that kind of matrix of disruptive forces, and how does it interact with all those traditional values that make Mercedes such a great company?
What most people think about when you talk about artificial intelligence in the auto industry is autonomous drive, smart cockpits, things like that. And if I put that into a historic context for Mercedes, where did that journey start? Actually, we had our first autonomous drive project going here in the mid-'80s, almost 40 years ago. And we had the first very, very crude version of machine learning for language understanding in the car in the mid to late 90s. What is different now, 25 years later? It is that the toys in the sandbox for the engineers are so much more powerful. We have incredible compute power in the vehicles. So you could say there's super compute capability inside a car linked to the cloud. Of course, we have the development of artificial intelligence, algorithms, machine learning, now Gen AI stepping into the mix as well. And we have much better sensing technology. So we can look around the car in all directions in an intelligent way and process and understand that information, and also look inside the car, what's going on inside the car, so you don't accidentally, leave your dog behind if it's hot outside. You get reminded to bring your dog with you. So what's going on now is that artificial intelligence is making autonomous drive real. We have certified the first so-called level 3 vehicle at Mercedes. It's the first commercial product that you can buy, where in some circumstances on the highway, you can't push a button, and it is the computer that is driving. Not only is that a technical challenge, you got to get through an army of lawyers before you decide to take that product liability on board as a car company. But also in the smart cockpit, you can more or less speak to your car now. We're launching next year what we call the Mercedes Virtual Assistant. There you have your digital AI-based alter ego in the vehicle to help you negotiate really any situation that is relevant in a driving context, much like Jarvis helps Tony Stark in the Iron Man movies. And this is really happening. So driving is becoming safer, for sure, much safer. It's becoming more convenient. in the case of autonomous drive, you get back the gift of time. You can then use your time for doing other things while the car drives you. So this is a revolution that is going on. It's going on fast, and the trajectory is steep. But it would be wrong to reduce artificial intelligence in the car industry just to those product features. I could name dozens examples throughout the whole company on the enterprise side and other product or production issues as well. So it's really happening everywhere.
How do you manage that just on this speed issue? I mean, one of the things people say about a car moving down a road today is, right, it's not a car, it's a million pieces in tight formation. Part of running a business like yours is it's not just Mercedes, it's this kind of universe, this whole ecosystem of, I would assume, relatively risk-averse, partners that you also got to get in line. Like you say, the speed is extraordinary. How do you think about balancing speed and a culture of risk at a place like Mercedes? And how does AI, is that a tool somehow to help you encourage people to take more risk?
Now is the time to actually think like the original founding fathers of our company, Gottlieb Daimler and Carl Benz, that actually invented the car. They were risk takers. They were engineers, inventors, pioneers. They pushed the boundaries. They were not afraid of anything. That's 138 years ago, and of course, a lot of things have happened since. But you mentioned it. The car industry is going through a once-in-a-century transformation, not just switching out the powertrain, but making the car now even more intelligent. So we need to be that entrepreneur again, and we need to pick up speed, decision-making speed, significantly. And we're doing it while thinking about the long term. It was mentioned that if you just focus on your quarterly earnings for the next 4, 6, 8 quarters, whatever it is, you're making a mistake. Now it's actually time to invest. And we have decided to invest on the highest level ever in our company history. A lot of it goes into the digital side of the vehicle and to the artificial intelligence. And then you watch what's going on in China. They're not waiting. There's the term China speed. Go, 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 go. We need to make sure that Stuttgart speed is the same speed as China speed, and make careful decisions. While at the same time, when we roll out features, we are Mercedes. The star stands for something. It stands for trust. We cannot do what maybe a startup can do and just put a beta version of some technology on the road and hope that the customer figures it out. Maybe there we are more thoughtful when going to market to make sure that it works, it's safe, it's mature. But in decision making, in investment, in grabbing the potential of the technology, we need to be that original entrepreneur all over again.
Vince, that notion of kind of trust, I think also, I mean, if you think about ADI products, which sit, for decades sometimes inside of people's architectures and ecosystems. One of the things I've been impressed by in that regard, just in spending time with you over the years, has been the focus you've had on sensing. I mean, every time I see you, every time I talk to you, it's just this translation from analog to digital. So much of the focus, I'd say, over the last 18 months has been in this purely digital realm of LLMs, where you're training things on corpuses of text, on adversarial data. Obviously, what ADI represents is the opportunity to build an incredibly thick, incredibly dense sensor network in real time that has, and Ola was talking about sensing, that will feed into these models. So you're not feeding the models on text, you're not feeding them on Shakespeare, you're feeding them on real-time pictures of the world. So I'm wondering if you could talk some about kind of what it is like now for you to be, I mean, you've been in the analog chip business forever, that layer for a very long time. There's this next, sort of to Reed's point, this next phase coming in the development of AI. A part of that is moving from an LLM model in the core towards a more edge-focused, sensor approach. That's ADI's core business. I'm curious, how are you thinking about kind of this revolution that's now starting to really rush towards you?
Yeah, well, it's a great question, Joshua. Yeah, we've been spending our time over the decades really at that delicate intersection between the world of physics, and now we're moving towards the world of biology, much more molecular interface between semiconductors and the areas of healthcare, smart agriculture, and so on and so forth. So I think if just to summarize some of what I've heard this morning here on the call, the emphasis over the last kind of 2 years since AI has really hit the tipping point has been around large language models, been around cloud and infrastructure. But what we see is the movement of an architecture from the cloud to the edge and back. And there's a very good reason to do that. I think, number one, we want to be able to use the tools and techniques of artificial intelligence to be able to collect the data from sensors that are important to the world of automation in automobiles, factories, and so on and so forth, and be able to make localized decisions that then can be acted upon. I think that's the thrust of ADI. And why is that important? Well, there is no need to push everything back to the cloud. There are reasons of security, latency, bandwidth preservation, and increasingly our customers are telling us the security side of the data equation is really, really important. As we've thought about security, I mean, for many, many years now, since the formation of the cloud, we've tended to think about it as a facet of the cloud. Security is a facet of the cloud. But we're paying more and more attention to being able to produce these rich data streams where the data is being generated, where the action needs to take place, and to keep it secure at the root. So basically, the real world becomes a root of trust for the data.
One of the themes that I think was very clear at the WIC last year, which is related to what you said, is just this incredible focus, I'd say particularly in the Chinese ecosystem, on latency and edge-related latency. And I'd say over the last year, I've heard a lot of discussion about latency everywhere I go. And then I think you hear increasing discussion about energy consumption, energy demands.
Yeah.
Are there breakthroughs in latency and energy coming forward on the edge that you think will be transformative, just as some breakthroughs, facilitated the training of LLMs?
Yeah, I mean, there are many problem sets, Joshua, that, you can use the cloud. You can push everything back to the cloud, but it's the old analogy. It would be using a sledgehammer to kill a fly. So the more you can do at the edge, inherently, you get the benefit of lower energy usage. Every time you move data, you're increasing its insecurity, but you're also increasing the power per bit to get the data to distant places. So that's a very, very important aspect of things. When we think about power in general, I mean, there's a computing norm that computing performance is equal to power. And that's increasingly important. So what we're being asked to do by many of the cloud companies, the grid companies, and even the chip providers themselves is to provide smarter techniques to enable better efficiency right at the creation or the generation of the energy, the distribution of the energy, and right down to the chip level. The density of power and computing are one and the same thing. So we're very, very busy using all the techniques in our power portfolio to be able to manage that problem from the grid right down to the chip.
We'll come back in a second. I think it's some of the kind of cutting edge work. I think the stuff you're doing in biology in particular is an example of the way in which just kind of the tendrils of sensing and machine intelligence are spreading very widely. I thought that I might turn just quickly to Reed on this subject, which is, Reed, I think one of the things you've been good at, as long as I've known you, is this idea of trying to create an image of where things are going. I think you have a strong sense that people need to have a picture of where things are headed. And probably the most, I don't know if it's the most well-known example of you're doing this, but certainly one that got a lot of attention last year was this conversation you had with yourself using a rendered version of Reed, which is, for people who haven't seen it, I super recommend it. I presume there's a version of it, of you're having a conversation with yourself where yourself speaks Chinese. Maybe we could arrange for that to get posted. But I'm wondering, what made you do that, and how's the reaction been?
Well, one of the funny things is in this acceleration, that was just earlier this year. That wasn't last year. And part of it was to show what's available with commercial technologies today. Like, I didn't use anything special, any special access to the OpenAI or Microsoft or other things. It was just, kind of go and go to some startups and, stitch their technologies together, video, audio. We used, kind of the marketplace GBT for, read AI's words, and then showed the discussion. And a bunch of people were fearful of in my teams over the fear for my doing that. They thought there'd be blowback. It's like, you're doing this deep fake. And actually, in fact, even though some people thought, well, that was kind of creepy, because you actually have me speaking to me and people kind of going, wait, which one is the real Reed and which one's Reed AI? And then later gave this speech in Perugia, which, had me, my Read AI, giving it in Chinese, Japanese, Hindi, Arabic, et cetera. So yes, there is that. In the Read to Read AI, I think we only used Spanish and Klingon, the Star Trek language, for anyone who's not tracking that, to give some of that. And I think part of it is to show what's actually already possible, what's already here. William Gibson, the science fiction author, has a very good quotation that it's good to remember, which is the future is already here. It's just unevenly distributed. And to kind of to show that that being here. And then what it can also be used in positive ways, because this is actually one of the things that's too often, in discourse around technology is like, well, deep fake, it's just bad because it's a deep fake. But actually, in fact, for example, take, being able to make human connection across cultures and languages. That's part of the reason why I had the Perugia speech, which is kind of like, in a sense, the speech that was, here is why to be technology forward, AI forward, delivered in a, kind of an intellectual European context as a way of doing that, and then put that in a large variety of languages. And that's all part of showing how this technology can be used in positive ways. And that's kind of the most often kind of drumbeat that I have within, kind of a lot of media and everything else, which is, look, whatever problem that you think that you're honestly trying to solve, technology, if it's a scale problem, is an essential part of the solution, even when it's a problem that you envision as being created by technology. Technology is the solution to that. And so how do you then, the discourse should be on how do you then shape it to then make that happen. And a little bit of that was the me talking to my AI, which I thought I would hate, and actually was more interesting than I had anticipated when I did it.
Yeah, I mean, I think it's also in the Perugia speech, which I think we can provide a link to. I think it also is you're giving a speech at one of the oldest academic institutions in Europe. They introduced you in Latin. And so this kind of idea that the solution to the problems of technology is more technology cast into an academic environment, I think that is the core accelerationist, I think, debate, which you framed very well. Speaking of academic environments, Steve, I think you've been probably the largest single philanthropic donor to academic work on AI. And I'm curious, Steve, you're just generally a very large philanthropic donor. How did you pick AI as a subject area? And how do you think about the distinction between the work that you've done in academia, the work to be done in industry?
Well, I think I didn't pick it. It picked me. Started an AI ethics operation at Oxford as part of a new humanities center I gave. And I did that because as everybody's rushing to STEM, and appropriately so, I saw the need to integrate that with sort of what happens to humans out of all this stuff, because it's going to change what human beings do 10, 20 years from now. And you have to think through some of that stuff. It also gets you into regulation, a variety of other things. And I found all that quite fascinating. So we had a group of that at MIT, a group at Oxford. And, now I'm sort of knee deep into this thing. And, I also part of the Stanford High, human artificial intelligence. They do great work. And, I'm interested in the whole regulatory apparatus globally, because people who work with this technology have a healthy respect for what can go wrong with it. So that's how I got involved. And I'm now a huge donor in this, and I get to see the interface, because we're also at Blackstone. We're, as Jenny said, we're in the picks and shovels business, apparently. And so we're doing a huge amount of business doing data centers. And we think we're the largest builder of data centers for AI in the United States, and hopefully will be in the world. And what's going on in that area is so explosive. I've never seen anything like this, frankly, from a standing start.
You because you kind of have been so involved in the education space, you're seeing, both the emergence of this kind of electric new discipline on university campuses, which is everything related to AI, and then kind of the overall adjustment to universities, everything that's been going on university campuses. Do you have a view about what does a great AI university of the future look like, and what's the relationship between the kind of work you're doing and the kind of energy that's going on there and the way that traditional university environments are trying to adjust to the world today?
Well, what's interesting is that universities are now at a disadvantage compared to the commercial world. And the breakthroughs are really going on the commercial side because they can afford all the compute time that you need to do the development. So I think you're going to have a different structure over time. The universities still have super smart people, but they're somewhat handicapped in this race. And I think there's going to start becoming more in the way of necessary some sources of compute time, which are companies for the most part, other than government, which is difficult to work with because they don't have a lot of money themselves, just given the way they're constructed with deficits. And you're going to have alliances, I think, over time in a much more thoughtful way that comes from just sponsoring a professor or something in their research. And that change is going to enable the universities where, frankly, so much of the knowledge base in the companies started in those university settings. So there's going to be more of a melding between those, if you were asking me to speculate.
Interesting. Jenny, Steve, a natural point that comes out of this is this issue of scale, which I think is a theme that kind of they probably risk and scale are the two things that come here, and whether or not there is this kind of winner-take-all network effect dynamic that's going to affect these businesses. Franklin Templeton today is obviously huge. You are very well known for having an extremely hands-on approach, right? That you're really capable of kind of onboarding people and thinking personally about it, about their savings, their investment. How do you see that playing out? I mean, do you think there will be a winner-take-all dynamic in the financial services space? And I'd say particularly when you think about the problems of aging populations, the nature of what's happening in public markets today, is there some kind of fundamental structural change you think that may happen in the business as a result of this?
So I'd say there are a couple things there. So from an investment side, I do think that scale is going to really matter, partly because just the underlying data that you'll have access to be able to train your own AI models to enhance any kind of investment process and decision-making is going to be really important. And data is really expensive. And if you're small, you're just not going to be able to invest where that needs to happen. So certainly from an investment standpoint, I do think that scale and size really matter. And you hear it from big distribution partners who say, okay, I got to narrow the number of partners I use because if there's a regulatory blow up, on one, it splashes onto me. So I'd like to narrow it. And I want to make sure that they're investing in those things so that I'm not going to have those problems. On the other side, from the delivery of wealth management services, you actually see a trend where you're getting many more individual RIAs who are setting up their own shingle because the technology has enabled them to do that. And there's a huge amount of inefficiency that happens in that process, right? Onboarding a new client is expensive. It takes time. You have to do KYC, AML. There's a lot of things that go into that. Tax optimization, tax reporting, right? All of those things are just administrative and they're not that value added. They have to be done well and right, but they actually take away from that time of kind of engaging with the client to really understand what the client's goals are. I think that efficiency can get squeezed out. Efficiency can happen there, and you're going to be able to then have that individual advisor spending more time focusing on the client. And as I think about probably the number one thing the average American worries about after, can I pay my bills this month? And, can I keep up with just paying my bills is, and then when I retire, will I have enough money after? Am I going to be able to stay in a home? And so that retirement component is going to get really complicated with this now. And AI is going to be important. If you think about the breakthroughs that are going to happen in medicine, longevity, right? If you're close to retirement now and you set your retirement goals when you were 20 and they told you your lifespan was probably 78, 82, something like that, and now we're talking about people living to 120 plus, you're going to need to have as part of your retirement plan, not just a target date to where your retirement is, but a dynamic target date as to, you know what, longevity's just changed. We're going to need to dial up risk in your portfolio because based on where you are now, you're not going to have enough. And so I think that those kind of tools are going to be really important, and you're going to customize portfolios. And actually, in the end, it's going to be a lot better for the end customer because we're going to get better at it. So you're going to get those efficiencies in the system, and you're going to focus the technology and the value add in the places that you really need to do it where it makes a difference for the end client.
And does that mean the creation of new financial products as well? I mean, do you anticipate that's an evolution ahead, or is it just kind of a layer that sits on the architecture that exists today?
Again, we're always the industry is always creating new products. I'm a big fan of blockchain. That sort of takes AI and blockchain. I think there'd be significant in a lot of ways. They're going to open up new types of investment opportunities that historically just went to either institutions or the ultra high net worth, and you're now going to be able to democratize those and give that access. And that's going to come in new vehicles, some of which are tokenized, others of which are pooled vehicles that have just evolved. So yes, I think you're absolutely going to see new types of investment opportunities.
Ola, Vince said something earlier, which I think is also to some degree, I think even related to what Jenny just said, which is there's this kind of relationship between compute and power, right? Which is, and therefore the efficiencies that come with scale and some of these other sorts of things. So one of the things we're seeing in the world today is there's all this new compute coming, and there's just these unbelievable energy and power demands. And I'm curious how you think about that. Obviously, in the auto business, you all were really on the leading edge of confronting problems of energy and climate change and thinking through that transformation. I'm wondering, how is AI shifting your thinking about that?
Let me maybe take two concrete examples. I'll start in our operations. In most car plants, the number one energy user is the paint shop, which is not a surprise. You need heat and a lot of energy to paint and also make the car e-coated, corrosion-proof, all of those different things. So you try to not just improve your CO2 footprint, you also want to improve your cost footprint when you optimize the paint shop. So we have been experimenting in one of our German plants, really feeding a model, an AI model, with all the historic information of how you operate that paint shop throughout the year, through different shift systems, throughout different seasons of the year, to see if AI can help us make a smarter decision for a better operating model of the paint shop in terms of energy usage. And it started to yield results. We're now operating at about a 20% better energy consumption or efficiency of the paint shop in that specific plant, not related to reducing volume or anything. So apples to apples, which means that artificial intelligence companion is now really starting to have an impact on our operations. And you can do that in many, many other areas as well. Predictive maintenance, so you make sure that the robot, you almost see if a robot is going to go down before it goes down, and you do the maintenance at the exact right time to keep your OEE up and keep the plant running. If I jump to the car, in the era of electric cars, it's all about energy efficiency. The energy density of gas or of diesel is so high that when you jump to a battery, even though we have very sophisticated battery chemistries now, the energy density of batteries is, of course, much smaller than what we have been used to on the fossil side. And for combustion cars, you had heat you had for free just by burning it. Now the engineers think in a different way. You try to save every watt in the car. So it's down to the last watt. And a lot of energy consumption goes back into that supercomputer that drives your autonomous drive systems. That is an energy consumer. So can you write your software in a way that you solve the same problem, but at a lesser wattage, down to the exact calibration of in the winter when you turn on your heated seats, that you don't waste any of that energy around the body, but it warms the body in a comfortable way in the exact right places and time. And their artificial intelligence, not just in terms of making the AI models efficient in their own right, but they help us to chase out inefficiencies. And I think we would not be as far as we are today without that tool. And it's only going to get better from this point forward. That's what makes me so excited. We talked about, I think, the electric grid. Are we now back to we're building the electric grid, but we don't know what we can do with it yet? It feels a bit like that. And I think we're building it, and there is so much more to come.
How do you think about, I mean, one of the issues here has obviously been consumer adoption habits. And it's been super interesting for me. I live in Shanghai. Everywhere you go, it's the green license plate. There's been no ambivalence about it. When I go back to the US, you ain't seeing a lot of the equivalent of green license plates, right? That transition to electric has been harder in the US. Do you think AI, but we also live in maybe just a footnote, say we live in a period where you do see these very rapid changes sometimes in consumer behavior. I remember a couple of years ago on the Starbucks board, we were talking about the one of the things that's happened in coffee has been this incredible shift from hot beverages to cold beverages. Literally over a 3-year period, it went from like 60% hot to 60% cold. Nobody saw it coming. So it does seem at certain moments, you have these incredibly rapid changes in consumer habits. I think people had hoped that would happen with electric vehicles. At least in the US, my sense is it's not happening as quickly as people had hoped. Do you think AI maybe falls into a different category where when you have AI-enabled cars, it's able to more quickly drive a transition to an electric vehicle environment?
There's no doubt that we're on a transition towards zero emissions. So I think the destination is clear. Is it going to be a straight line? Maybe it's not going to be a straight line. On the drivetrain side, it's such a big industrial apparatus that need to change. It's the charging infrastructure. It's making sure that the electricity that we use come from non-fossil sources, and. So that incredibly large industrial flywheel takes a little bit of time to switch over. Maybe we shouldn't be so surprised. Maybe 3-4 years ago, we were too optimistic. But now that we are in the more realistic phase, let's not lose sight of where we're going. We're going towards zero emission. There are no ifs or buts. And we're going to continue investing into that, regardless of maybe less dynamism in the market at this point in time. So it's coming. With regard to AI, I think that's also coming everywhere. Of course, you have different types of customers. The typical customer of Mercedes in China is much younger. Take a top-of-the-line product in our product portfolio is the S-Class. It's like the pinnacle of automotive engineering. And when you buy your first S-Class in the US or in Europe, you're probably, I don't know, between 55 and 60. And it's the final reward now that you have come to the top of the Mercedes pyramid. Well, look at the customers in China. Actually, the average S-Class customer is just below 40, between 38, 39, 40. And the digital smart cockpit for those customers, tech savvy, open-minded towards tech, is hugely important. But I think that it's almost like the younger generation always drives in terms of technology than what the maybe young at heart generation then adopts as well. So if we can sing karaoke in the new E-Class in China today, maybe we'll sing karaoke in the E-Class in New York City a couple of years from now. So don't underestimate how quickly this goes as well, which we're across the board for all customers in all vehicles into this. And if anything, on the smart cockpit side, ADAS, as I mentioned, it's going faster.
Yeah, I mean, by the way, that's exactly what we saw in the coffee space, which was the millennials were drinking cold coffee. And then they drove it up to the Gen X and the boomers. It basically had a contagion in preferences that moved across the stack. And what's interesting about auto is it really is kind of a litmus test. I mean, as all of us know who work in China, Chinese always want the best, the newest, the most impressive technology. And autos in the US, at the moment, people are not moving quite as fast in that same direction. So in a way, your industry is a fascinating kind of snapshot into kind of a global temperament on these things. Vince, I'm wondering, I want to kind of drag you over to the biology question at least a little bit, because I know you spend so much of your time on it right now. I think everything we've been talking about here is the world of electrons, the world of atoms, all these kinds of things.
Mm-hmm.
Can you give us just like a little preview into what's going on in terms of sensing in the biological space and how that's feeding into an AI ecosystem?
Yeah, sure. So maybe I'll take two examples. One is if you look at the healthcare system today, investments are increasing at a serious compounded rate every year. Productivity is coming down. So the focus today is very much on sickness rather than wellness. And so our belief is that, first off, our technologies really, everything we do is in the service of improving the health and welfare of humans and increasingly the planet. So on the healthcare side, we just got FDA approval for a cardiopulmonary device. It's a very, very small sensor. It's probably the size of a quarter that sits on the left chest cavity. And that thing is capable of reading, it's got a lot of sensor modalities, of course, but it's also got some artificial intelligence. We've got libraries of references that we can bring to bear. But it's capable of reading primary, secondary, tertiary signals that relate to the interaction of the heart, lungs, and kidneys. And we've targeted that technology today to the areas of congestive heart failure and COPD. So the whole idea is basically to get an early predictive detection of the deterioration of a particular health modality. And those two in particular, we've started there. So this is a platform that essentially is designed to keep people out of hospital. Or if people are really in need of hospital care, the ones that need the interventions, get there quickly. So it's all about, the whole process is about getting insights to information time down and down and down, making that seconds rather than hours or days. We've another platform we're building, which is today targeted at bacterial detection. So we see enormous application in healthcare and industry. And essentially, the initial device is capable of literally taking the bacteria onto the surface of the chip and using, again, artificial techniques and reference libraries to figure out what strain of bacteria we're dealing with. So again, you get, in the emergency room, you get time to information and cure very, very quickly before. And in the emergency room, that's obviously critically important, where today, if you arrive into the emergency room with a fever, blood is drawn, the blood is cultured, and so on and so forth. That can take anywhere between 2 and 5 days to get a pretty binary response. Is there a bacteria there or not? But the whole focus is to be able to figure out, yes, there is a bacteria there, but it's this strain of bacteria. Therefore, the cure can be applied quickly. So the whole process is getting from days to hours and minutes over time. And these are not just imagined technologies. These things are working today. But I don't underestimate the inertia that exists in the healthcare system and the adoption of, as Ola pointed out, digital natives will naturally take this technology, but it's going to take us time, I think, to turn the tide towards wellness from sickness. But I'm very, very hopeful that we're reaching a tipping point.
How are you thinking about it? I think one of the things when I was, as I mentioned earlier, last year's WIC was all latency and sensing. I think I called you when I got back. It was just like, man, it's like wall-to-wall sensing. It's like all the discussion was. Are you finding, I remember walking around sort of some of the spaces where you're starting to bring on bioengineers and other stuff. From your perspective, is it all just data and it doesn't matter, or is biodata kind of qualitatively different in the way you think about instrument?
It's a great question, Josh. If you look at the last 50 years of what we've done, we've essentially provided the interface between physical systems that they're continuous time, but they're relatively predictable. Biological systems are systems of systems of systems. They've got a lot of emergent properties.
Yeah.
And we see artificial intelligence, the learning part of artificial intelligence, as a very, very critical tool to be able to get to the other side of the mysteries in these emergent biological dynamical systems.
Yeah, that's super interesting. I mean, I think that distinction between a complex system and a complicated system, right? A complicated system is a jet engine, millions of pieces, or a car, you can build it over and over. Complex system has these emergent properties. Once you start, they're probably only tractable through the kind of sensing architectures you're talking about because you can't train on them.
Exactly.
Interesting. Well, look,
we will use essentially, Joshua, the same sensor modalities, but the application of AI that gives us the opportunity to build a learning system that keeps ahead of the complex behaviors of these biological systems.
Yeah, I mean, it's extraordinary, right? It's the difference between instrumenting a car and instrumenting the human body. Like you say, it's just a radical thing. It's incredibly interesting. Well, I can't thank everybody enough for your time. This has been an absolutely fascinating conversation, as I probably could have expected. What's amazing is, finding kind of continuities across all of these different disciplines and just the extraordinary, disruption and possibility that's ahead for all of us. So let me thank you all again, and hope to see you in real life at the WAIC at some point. But I wish everybody a very good day, and thank you for your time.